Hey guys, this is the notes video for 2.2. This deals with proving lines are parallel. In our Google Meet, we went over the warm up together. So I'm just going to start by going through the theorems as well as, so all the theorems and then through the rest of the notes. So our first theorem, this is converse of corresponding angles theorem. Okay, so what we're going to think of is going the opposite way of solving or proving our corresponding angles theorem. So we're going to kind of work backwards. So it says if two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. So, right, see how these are corresponding. So angle 1 and angle 2 are corresponding. And, right, they are congruent. So if they're corresponding and they're congruent, then L and M we can say are parallel. All right, and this means parallel. Okay. So before, right, if for the corresponding angles theorem, we were given if L and M are parallel and they're cut by a transversal, then all corresponding angles are congruent. Well, if we're given their corresponding and congruent, we can say those two lines are parallel. The next one is alternate interior angles theorem. Same thing, we're going to work backwards. So if two lines in a transversal form alternate interior angles, so 1 and 2, we see the two arcs, that tells us they're congruent. So form alternate interior angles that are congruent, then the lines are parallel. So we can say L and M are parallel, right, because angle 1 and angle 2 are alternate interior angles and congruent. Therefore, L and M are parallel. The next converse, it's a postulate, is the same side interior angles postulate. It says if two lines and a transversal form same side interior angles, so we see 1 and 2 are same side interior. Well, we know if they're same side interior, right, and they're supplementary, meaning they add to 180, then the lines are parallel. Okay, so if angle 1 and angle 2 are same side interior angles, and supplementary, meaning they add to 180, then we can say L is parallel to M. Okay, and then the last kind of converse theorem that we're going to go through is the converse of alternate exterior. All right, so if angle 1 and angle 2 are alternate exterior angles and congruent, which they are, so angle 1 and angle 2 are alternate because they're on opposite sides of the transversal, exterior because they're on the outside angles, and are congruent. We have the two arcs around 1 and 2 saying that they're congruent. Then line L is parallel to line M. Okay, so alternate exterior angles and congruent, then they are parallel. All right, now the last two theorems, they don't really have a name, but we can kind of name them after. This says if two lines are parallel to the same line, then all are parallel. So all three are parallel to each other. Okay. What we can say is this is parallel transitivity, meaning we're using the transitive property to prove these are all parallel. So you could call it parallel transitivity. All right, so we see that A is parallel. So if A is parallel to C, and see how there's two arrows? So B is parallel to C. So that if they're both parallel to C, then A needs to be parallel to B. All right, so that is that theorem 2-8, which we can call parallel transitivity. Then the last one is a theorem about parallel and perpendicular lines. So perpendicular lines, they make this like T shape, and they create four right angles from their intersection. Okay, so we can see the four right angles for intersection AC and intersection BC. So it says if two lines are perpendicular to the same line, so if A is perpendicular to C and B is perpendicular to C, then A has to be parallel to B. Okay, so if A is perpendicular, so upside down T is the perpendicular sign. It's perpendicular to C, and B is perpendicular to C, then we can say A is parallel to B. Okay, and those are all of our theorems. All right, now this problem, don't stress about. There might be one random question on the Math Excel about it, but this is just kind of showing you a different way to do a proof. We've gone through two column proofs. This one is called a flowchart proof. So instead, two column proofs, right? Two column. Right, the left, right, it looked like this. This was our statement, and this was our proof, right, or our reason. Right, so statements on the left, reasons on the right. Now for a flow chart, right, on top, we're going to have the statement, and then below it, we're going to have the reason. So on top, and then on bottom. All right, so this, you can see, is our statement, right? Angle 1 is congruent to angle 2. And our reason is that it's a given. Right? It comes from our given over here. Okay. Now we look down here. It says angle 1 is congruent to angle 3. Right? How is angle 1 and angle 3 congruent? Well, they're vertical angles. So the vertical angles theorem tells us that vertical angles, angle 1 and angle 3, are congruent. Now, the next one, we're given the reason, right? So we need to write the statement. The reason is the transitive property of congruency. So we're going to look for two things equaling the same thing, right? So both 2 and 3 are congruent to angle 1. Therefore, by the transitive property, angle 2 is congruent to angle 3. Right? So now we have angle 2 is congruent to angle 3, angle 1 is congruent to angle 2, and angle 1 is congruent to angle 3. Now, we can say that line L and M are parallel because we know 2 and 3 are congruent, right? And 2 and 3 are corresponding angles. Therefore, the converse of corresponding angles theorem. right? That tells us that if we have corresponding angles that are congruent, then line L and M are parallel. So we can prove alternate interior angles theorem by using the converse of corresponding angles theorem. But this was more or less to show you how a flow chart works. All right, now this is a real world example. Okay, it says determine whether the lines are parallel. The edges of the new sidewalk must be parallel. So here's our edges. Right. Let's call this like L and M. Those are our edges. Then we have a transversal here. That'll be our T, or our transversal. Okay. So if we look, right, we have these two angles here, 53, right? 53 and 53 are obviously congruent to each other, right? And what type of angles are they? Well, 53 degrees and 53 degrees are, right? They're on opposite sides of our T, our alternate. And then on the outside, right? They're on the outside of our two parallel lines. So they're alternate exterior angles. And 53 degrees, right, is equal to 53 degrees, which means they're congruent. Now, if they're congruent and alternate exterior angles, then by the converse of alternate exterior angles theorem, right, which is if two angles are congruent and they're alternate exterior, then the two lines are parallel. Line L is parallel to line M. So edges of sidewalk are parallel. Right. So he knows that they are parallel because their alternate exterior angles are congruent. All right. All right. Now in this problem, this gives us that angle 3 is 43 degrees. Now, we're going to use the fact that we have parallel lines and transversals to give all of the degrees for all of these angles, right? So our first thing is to find all of the angles that we can see that are congruent to 3, right? So angle 3 is congruent to 5 because they're vertical angles. So 5 is 43 degrees. Angle 3 is congruent to angle 12. Oh, sorry, not 12. Angle 13 because they're alternate exterior. All right, so these are vertical. 13 is 43 degrees because alternate exterior. Right, and then angle 11 because they're corresponding. Okay, now let's look at 3 and 4. Angle 3 and angle 4 are a linear pair. Therefore, they equal 180 degrees. So, this is 43 degrees. Angle 4, right, needs to be 137 degrees. Right, so angle 4, 137 degrees because they're a linear pair. All right, now this is 137 degrees. Now let's find all of the pieces that, well, actually, let's continue finding the congruent to angle 3. If we look, angle 1 and angle 3, if cut by the transversal C, they're corresponding. So angle 1 is 43 degrees. They're corresponding. Now, angle 1 and 7 are congruent. So now 43 degrees for 7, right? They're vertical. Vertical to 1. And 15 is 43 degrees because it's alternate exterior to 1. And then 9 is 43 degrees because it is corresponding to 1. Okay. And then it looks like we found all of the ones that are equal or congruent to 3. Now let's look at what's congruent to 4. Well, 6 is vertical to 4, so 137 degrees vertical to 4. Alternate exterior would be 14, so 137. Alternate exterior to 4. You don't have to label why they are. I'm just labeling it so you guys know how I'm getting them. 12 is corresponding to 4, so 137 degrees corresponding to 4. 2 is also corresponding to 4, so 137 degrees. Okay. 8 is vertical to 2, so vertical to 2. 10 is corresponding to 2. You see I'm making the double arcs. That's because to separate from the single arc one. And then 16 is alternate exterior to 2. So it's congruent. Okay, so these are our solutions. And then I gave the reasons to the right. Okay. All right, now the last piece is knowing those facts of all these theorems and then using algebra in them. So we have angle 5, right, is 2x minus 10. Angle 6 is 4 times y minus 25. And then angle 7 is x plus 15. Okay. Now, right, we're going to use the facts, right? We should know angle 5. Measure of angle 5 is equal to the measure of angle 7, right? Because they're corresponding. Okay, so we can set their equations equal to each other. So 2x minus 10 equals x plus 15. Okay, and let's solve for x. So if we subtract an x over, x minus 10 equals 15. So x, right, we add 10 to both sides, x equals 25. Okay, now let's find out. So angle 5, we said, is equal to 2x minus 10. So I'm going to plug in 25 for x, right? Because we got x is equal to 25 here. And then I'm going to solve for angle 5. So angle 5 equals 50 minus 10, which is 40 degrees. Now we need to solve, so we found x, right? We need to solve for y, okay? So the equation with y is angle 6. If we look, angle 5 and angle 6 are equal to each other. So angle 5 equals angle 6, right? The measures, because they're alternate exterior. So angle 5 we said was 40 degrees. Angle 6 is 4 times y minus 25. So now we can solve for y, right? Divide both sides by 4. 10 equals y minus 25. And then add 25 to both sides. And we get y equals 35. Okay, so, right, we find the equations that both have x's, right? And then you can solve, right? And then what you want to do is find, once you solve for x, then you're able to solve for the y part because you can plug in x into those equations you had. Okay, so that's one of them. Now let's go on to the next one. So again, we're finding x and y. All right, so now let's look and pull out, let's look at 4x and 56, okay? So I'm going to pull out those two lines that contain them. And then the transversal. We have 4x here. We have 56 degrees here, okay? Now, this is also equal to 4x because it's vertical angles. So I just put a 4x here. Now, 4x and 56 degrees are same side interior, so they add to 180 because they're supplementary. So I'm going to say 4x, they add to 180, so plus 56, not 46, 56 is equal to 180 degrees, right? They add up to them because they're same side interior, which means they are supplementary. So now we get 4x, right, minus 56 to both sides. And we get 4x equals 124 degrees. And the last step is to divide both sides by 4. So we get x equals 31. Okay. So x equals 31. Now, all right, let's look at so we can either use our 4x here and plug in the x for it and then compare it to our 3y minus 11, or we could do 56 and 3y minus 11, and you'll see that they're going to be supplementary as well. But let's use the 4x, okay? So let's solve for this 4x angle, okay? So 4x, we said that x equals 31, so 4 times 31 will give us the degree here. So 4 times 31 gives us 124 degrees. So this is 124 degrees. That doesn't look good. 124 degrees. All right, so now we want to solve for this y. So let's pull out this line here, and then it's transversal. Okay, so you don't need to use all the lines inside the picture. All right, so we have 124 degrees right here from that 4x. And then we have 3y minus 11 down here. Now, these are alternate exterior angles, right? So 124 degrees and 3y minus 11 are alternate exterior angles, which tells us they're congruent. So we set them equal to each other. 124 equals 3y minus 11. Now we add the 11 to both sides. We get 135 equals 3y. Therefore, y divide by 3 to both sides, and y equals 45. Now we solve for x and we solve for y. Okay, so this is how we do it algebraically if we're given variables in our angle places.